How are you doing, students? Welcome to another lesson. Today we are going to study chemistry and we are going to study about the structure of the atom and the periodic table. This is the first topic in Form 2. I am your teacher and host, Boaz Omoy William. I hope you're doing okay. Ensure that you take a pen and a paper because we're going to have a very important chemistry discussion. Now, in Form 2, the first topic in Form 2 is the structure of the atom and the periodic table. This is a very important topic and it lays the foundation for most of the chemistry that we'll be doing as we proceed. I will not discuss the structure of the atom because it is very simple. Structure of the atom is that it has a nucleus and electrons surrounding the nucleus, and within the nucleus we have the protons and neutrons. So basically that is the structure of the atom, but I'll talk more regarding the periodic table. Now, the periodic table is an integral part of chemistry. It forms part of inorganic study, and in that I mean inorganic chemistry. Remember, there are 4 branches of chemistry. We have organic chemistry, inorganic chemistry, physical chemistry, and analytical chemistry. So the periodic table falls under inorganic study and inorganic chemistry. Now I want to say something very important. The periodic table is a list of chemical elements, all the chemical elements in chemistry. It is a list, it is a grid, it is a table, as even the word suggests, the periodic table. It is a grid of chemical elements, and basically all of them, 118 chemical elements which are known to date, they are all listed together in the periodic table in a special way, and we are going to look at that as we move on. Now, if you look at the periodic table, it is divided into 2. It has rows and it has columns. And the rows, they are called periods. The columns are called groups. So mainly the periodic table is made up of periods and groups. In terms of representation, a group in the periodic table is numbered using Roman number, and a period is represented or numbered using a numeral, a Greek numeral. So if you want to write a group for a certain chemical element, you have to use a Roman number. That is how it is supposed to be written. And if you want to write the period for a particular element, you have to use a Greek numeral, a numeral 1, 2, 3, the normal numbers that we use in mathematics. I want to take you through the periodic table very fast. There are 118 elements discovered to date. And if you look at the periodic table, atomic number 1 in the periodic table is an element called hydrogen, then helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium with a capital K, and calcium, which is atomic number 20. Those I have mentioned are the first 20 elements, and you all need to know them by name and by chemical symbol. Moving on, atomic number 21, we have scandium, titanium, vanadium, chromium, manganese, which is atomic number 25, and the chemical symbol is capital M, small n. Then we have iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, and krypton, which is atomic number 36. And krypton has an atomic number 36, and the chemical symbol is capital K, small r, as you can see. Moving on, we have rubidium, strontium, yttrium, zirconium, niobium, molybdenum, technetium. We have ruthenium, rhodium, palladium, silver, which is atomic number 47. As you can see, silver has a chemical symbol of capital Ag. It is Ag and not Si, as some of you usually represent it. Chemical symbol for sulfur is Ag from argentum. Moving on, we have cadmium, we have indium, which is atomic number 49. Then atomic number 50, we have tin, antimony, beryllium, iodine, xenon, cesium, barium, which is atomic number 56, and barium is represented by capital Ba. That is the chemical symbol for barium. Moving on, we have lanthanum, cerium, praseodymium, we have neodymium, promethium, samarium, and europium, which is atomic number 63, and europium is represented as capital Eu. Moving on, we have gadolinium, terbium, dysprosium. Dysprosium is atomic number 66, which is the Dy, capital D, small y. Holmium, erbium, thulium, and ethapium. Ethapium is atomic number 70, which is represented by a chemical symbol capital YB, ytterbium. Moving on, we have lutetium, which is atomic number 71. Atomic number 72, we have hafnium, represented by capital HF. Moving on, we have tantalum, and atomic number 74, we have tungsten. Tungsten, which is used in light bulbs as a filament, are represented by atomic number 74 and chemical symbol capital W. Moving on, we have rhenium, osmium, iridium, platinum, which is atomic number 78. Platinum is a very important element, and it is represented by a capital P and small t, PT, that is platinum. Moving on, we have gold, mercury, and thallium, lead, bismuth, and polonium, and astatine. Astatine is atomic number 85. Now remember, astatine is very important, just like chlorine, fluorine, and others. It is a halogen, which is very important. I want us to continue, and we move on. Let's move on to atomic number 86. As you can see from the periodic table, atomic number 86 is radon. Then we have francium, radium, actinium, thorium, and protactinium. Protactinium is atomic number 91, which is represented by chemical symbol Pa, capital P, small a. That is protactinium, atomic number 91. Moving on, we have uranium. Uranium is atomic number 92, represented by a capital U. Moving on, we have neptunium, represented by NP, and then we have plutonium, represented by Pu. Moving on, we have americium and curium, and curium is atomic number 96, represented by capital C, small m, Cm. Moving on, we have atomic number 97, berkelium, represented by Pk. Then we have californium, einsteinium named after Sir Einstein. That is atomic number 99. Einsteinium is atomic number 99, represented by capital E, small s. Moving on, we have atomic number 100, fermium. And fermium is represented by capital F, small m. Moving on, we have atomic number 101, which is Mendelevium, named after Mendeleev, and that is chemical symbol capital M, small d. Moving on, we have Nobelium, which is atomic number 102. Moving on, we have Laurentium, which is number 103, represented by capital L, small r. Moving on, we have Rutherfordium, Rf. Moving on, we have Dubnium, which is number 105, represented by D and small b. Moving on, we have Sebogium, which is number 106, represented by Sg. Moving on, we have Borium, which is number 107, represented by Bh. Moving on, we have 108. Atomic number 108 is Hassium, represented by capital H, small s. And moving on, we have atomic number 109, which is Meitnerium. Meitnerium is atomic number 109, represented by chemical symbol capital M, small t. And so forth up to atomic number 118. So those are the elements in the periodic table, and I hope you have known them by chemical symbol and by name, which is very, very important. Now I want us to move on a little bit and we talk about something very important, which is called chemical families. Now the periodic table is divided into chemical families, and these chemical families are simply the groups. Now as you can see, we have so many groups in the periodic table. The groups are the columns. As you go downwards, the columns represented on the grid of the periodic table, those ones represent the groups. Now we have about 18 groups in the periodic table. I'm not going to talk about all of them, but I will talk about the most important groups. So there are 18 groups, but I may touch on some of them. And if you look at group number one, chemical family group number one, the name to group number one in chemistry, we say group number one is called the alkali metals. That is group one. Group number two, these elements are called, they have a special name, alkali earth metals. Those are elements in group 2. Then we move on. We have group 7 elements. Group 7 elements are called the halogens. Sometimes people call them salt producers. We move on. Group number 8, we have the noble gases. Group number 8 is also called the group O or group 0. These chemical elements are called the noble gases. Now if you look at your periodic table and if you look at the video, you can be able to see the periodic table that I have projected there. We have other groups and other elements. Now we have in between group 1, in between group 2 and group 7, we have those elements there. I hope you can see them. Those ones are the transition elements, the transition metals. They are found between group 2 and group 7. So those elements in between there, they are called transition metals. Now, if you check closely, in those transition elements, if you check closely, we have elements that are between atomic number 56 and atomic number 72. If you check closely, you will be able to see those elements. Now, those elements between atomic number 56 to 72, in fact, atomic number 57 is called lanthanum. So those elements which are between atomic number 56 to 72, they are called lanthanides. They form the lanthanoid elements. So they are called lanthanides. They include lanthanum, which is atomic number 57. If you look closely, you'll also be able to see in the periodic table we have elements between atomic number 88 to atomic number 104. Now, atomic number 89 is actinium. Now, those elements between atomic number 88 to atomic number 104, those ones are called actinides. Actinides, or the actinoid elements. They are also when you join the two, the lanthanides and the actinides, these two groups, they form what we call the rare earth elements or metals. The rare earth elements. So the actinides and the lanthanides, they are rare earth elements or metals. Now, if you also look closely in the periodic table that I have shown there, you will be able to see these elements that I'm going to name. You'll be able to see boron, you'll be able to see silicon, you'll be able to see germanium, and you'll be able to see arsenic, atomic number 33, and you'll be able to see atomic number 51, which is antimony, and you'll also be able to see atomic number 52, which is beryllium. Those elements that I have mentioned, they are called metalloids. Those elements are also called semiconductors. The metalloids or semiconductors. Now, having said that, all these elements, all these groups that I have mentioned, we can just say that in the periodic table, we have two broad categories of elements. Having known that group 1, they are the alkali metals, group 2, they are alkaline earth metals, group 7, they are halogens, and so forth, we can generally say that the periodic table is divided into metals on the right and non-metals. The periodic table is divided into metal or metallic elements, and metallic elements, in fact, all metallic elements, they tend to be to the left. They are to the left of the periodic table. And non-metals, they tend to be on the right, the far right of the periodic table. So those are the two broad categories of chemical elements in the periodic table: the metals on the left and the non-metals, which tend to lie to the right of the periodic table. That is the discussion on those elements and the chemical families and the groups. Then we have the periods. Now the periods, we have 7 periods in the periodic table, and the periods are the rows. The rows on the periodic table, those ones are the periods. Those are the periods, and there are only 7 periods. Now in chemistry, we are going to study only the elements in period 3, in future as we move on with the syllabus. So there are 7 periods, but our scope dictates that we study only period 3, and that one we are going to do it as we move on with the syllabus. I want to move on and talk about something very important: the atomic number and mass number. Atomic number and mass number. Now, if you look at an element in the periodic table, it is represented in such a way that it has 2 numbers. If you look at hydrogen, it is represented in the grid having 2 numbers, one on the top and one at the bottom. Now, the number at the top is the mass number. The number written at the top is a superscript, and that is the mass number. The superscript, it is the mass number of the element written at the top. The number which is below is a subscript. The number written at the bottom is a subscript, and that one is the atomic number. Very important. So ensure you understand the mass number, where it is, and also you understand the atomic number, where it is written. The mass number is always at the top, it is a superscript, and at the bottom we have the atomic number, which is a subscript of the same. Very important, very important. Now, I want to define these 2 terms, atomic number and mass number. When I am talking about atomic number, this is the number of protons in the nucleus of an atom. The number of protons in the nucleus of an atom. That is the atomic number. So when you see the atomic number, remember, this is the number of protons only. Moving on, we have the mass number. Mass number written at the top as a superscript. Now, in simple terms, the mass number is the sum of protons and neutrons. The sum of protons and neutrons. If you add the neutrons together with the protons, then you'd get the mass number. It is the sum of protons and neutrons for a particular atom. Now, I want to move on a little bit and talk about something very important, which we all must know: isotopes. Now, we have atoms which have the same number of protons, but however, they have different mass numbers. Atoms of the same element which have the same number of protons, but they differ in the mass number. Those atoms, we call them isotopes. Isotopes. So in simple words, isotopes are atoms of the same element with the same number of protons but different mass numbers. An example is chlorine 35 and chlorine 37. What do I mean? Chlorine 35, if we were to represent it using a superscript and a subscript, we'd write capital Cl and 35 and 17. 35 is the mass number and 17 is the atomic number. This means that chlorine 35 has got 17 protons and 18 neutrons. When you add them together, 17 plus 18, it gives you 35. Therefore, that is an isotope. That is an isotope of chlorine. That is chlorine 35. Looking at chlorine 37, you would see that when we write chlorine 37, it is Cl 37 and 17. So the number at the top is the mass number 37, and below there we have 17, which is the atomic number. Therefore, it means that chlorine 37 has 17 protons. Just like chlorine 35, it has 17 protons, but it has 20 neutrons. When you add them together, that gives you 37. Therefore, chlorine 35 with 17 protons and 18 neutrons is an isotope of chlorine-37, which has 17 protons and 20 neutrons. I hope you have understood the meaning of an isotope. This is a very common question in the exams, to define an isotope. So in case you'll be asked in the exam what is an isotope, you say isotopes are atoms of the same element with the same number of protons but different mass number. That is the correct answer. Up to that point, I think we have discussed everything and the most important sections that we need to know under the periodic table of elements in chemistry. So up to that point, I come to the end of our lesson today. If you have any question you want to ask, you can write it in this comment section below, and ensure you subscribe to this channel so that you can get more lessons that are going to be forthcoming. Thank you and bye-bye.